Hello there! For today's video, we will talk about the Newton's laws of motion. But who is this Newton we are talking about? We are talking about Isaac Newton, who was an English mathematician, physicist, astronomer, theologian, and author, who is widely recognized as one of the most influential scientists of all time and as a key figure in the scientific revolution. By studying the Newton's laws of motion, we will better understand and accurately describe the motions of objects and the forces that act on those objects around us. The first law of motion, or the law of inertia. But before we talk about the first law, let us first define inertia. Inertia is a tendency to do nothing or to remain unchanged. For the first law, an object at rest remains at rest, or if in motion, remains in motion at a constant velocity unless acted on by a net external force. Example: ball at rest will remain at rest if there will be no external forces applied to it for the first case. Or if you roll the ball, it will keep on rolling forever. Yes, you heard it right. Forever. In a straight line, if there are no external forces who will act on it, such as gravity and friction. That's it for the first law of motion. Now, for the second law of motion. For the Newton's second law, a particle with a force acting on it has an acceleration proportional to the magnitude of the force and in the direction of that force. Or simply, force is equal to mass times the acceleration. For example, if you pick a ball and drop it free fall, say the ball has a mass of 1 kilogram, due to gravity, its force will be the mass of the ball multiplied by the gravitational acceleration. It will be 1 kilogram times 9.807 meters per second squared and will be equal to 9.807 newtons. That's how many newtons you have for that ball. That's it for the Newton's second law of motion. Now, for the third law of motion. The forces of action and reaction between interacting bodies are equal in magnitude and opposite in direction. Or simply saying that for every action, there is an equal and opposite reaction. For example, back in example 2, as the ball hits the ground also puts an equal force back onto the ball, making the ball bounce back. The ground pushes the ball up. This happens because balls are made out of an elastic material which allows them to be squashed or stretched and then returned to its original shape. But each bounces will be shorter until the ball would stop bouncing. It is due to the downward pull of gravity which pulls the ball towards the ground. That's it for the Newton's laws of motion. Let us keep on learning. See you!